This is a screencast of extra credit problem number 11 from problem set 6-5. Here we have a 5-gram bullet moving at 600 meters per second, penetrating a tree trunk to a depth of 4 centimeters. It says to use work and energy to find the magnitude of the force that stops the bullet, and assuming that the frictional force is constant, determine how much time elapses between the moment the bullet enters the tree and the moment the bullet stops moving. Well, initial conditions over here to the left, we have a bullet moving at 600 meters per second. Its kinetic energy is 1/2 mv squared. Being careful, we have to convert the 5 grams to kilograms, and that's 0.005 kilograms, times 600 meters per second squared, gives us 900 joules is the initial energy. The final velocity, of course, stopped by the tree, is 0, and therefore the kinetic energy finally is 0. So the tree must have done work on the bullet in order for this to have occurred. So our equation of conservation of energy now, because we do have losses, is the initial energy plus any work done between the initial and final points is equal to the final energy. In this case, the work done by the tree, since it's acting as a force in the opposite direction of motion, will turn out to be negative. So let's set this up. We have 900 joules is the initial energy, plus the work, plus the work that's done by the tree trunk between points initial and final is going to equal 0, which is the final energy. We can solve this for the work done, and it's in turn equal to the force exerted by the tree trunk times the distance the bullet travels as that negative work is being done on the bullet, is going to equal 900 joules. And we can put the negative in here because basically when we bring that over to the other side of the 900 over the other side of the 0 here, or the other side of the equal sign, we get that as a negative number. We can solve for the force because this distance, we're told, is 4 centimeters. We have to convert that to meters, so that's 0.04 meters. And solving for force in this equation, one unknown, we get the force is equal to minus 22,500 newtons. So that's the average force that's acting through that distance, doing negative work on the bullet to take all that kinetic energy out, ultimately dissipated as heat by the tree. Next question is to determine how much time elapses between the moment the bullet enters the tree and the moment the bullet stops moving. Well, that force that we've just calculated, that negative force, is equal to the mass times the acceleration of the bullet. That's equal to minus 22,500 newtons. Is equal to the mass. Given the mass of the bullet is 5 grams. Again, we have to make sure that's in kilograms because that's the standard unit in the SI system. And we can solve for the acceleration. The acceleration is equal to negative 450, sorry, it's 4 more 0 there, so it's 4.5 million meters per second squared. It's a heck of an acceleration, actually, a deceleration, stopping that bullet, slowing that bullet down. How does that time? We need a relationship to solve for time. Going back to our relations of kinematics, we know that by the definition of acceleration, that v final is equal to v initial plus acceleration times time. The v final is 0. The v initial is 600 meters per second. So we can plug these numbers in here. We have, we have 0 is equal to v initial, 600. I'm going to leave the units off for the time being. Everything is in consistent units. Plus acceleration, which is minus 4.5 million meters per second squared times time. We can now solve for time. we get time is equal to minus 600, all divided by minus 4,500,000 meters squared per second squared. And that comes out to be 0.0001333 seconds, or about 0.13 milliseconds. If you have any questions, by all means give me a PT or general question thread and I'll be sure to answer it. Thank you very much.